Okay, for this lab demo, I've used the freezing point depression formula to figure out the molar mass of benzoic acid. There's a quiz about it. You're gonna do that. Watch the video, then do the quiz, and then I also want you to do the following. I would want you to send me in a worksheet, basically a table, the tables and calculations of the. So let's go through it. So part A of it is I measure the mass of lauric acid, and I want you to record that, okay? And that's in the video. And also it's freezing point. Now remember, it's a separate picture of it, and I believe it's somewhere around we decided the freezing point's around 42 degrees, but check that out. Write that down. Actually, we don't need this value because the freezing point is independent of how much the mass is. But we did it anyways, and we found out the freezing point of the lauric acid. Now, part of this, what we're going to do is we're going to take the lauric acid, and it's going to be the solvent. Okay, and then it has a freezing point, somewhere around 42 or 43, and then we're adding benzoic acid to it, and benzoic acid is going to lower the freezing point. Okay, we talked about colligative properties, and we use a formula, and then what we do is use the change in temperature to figure out the relationship between molality and freezing point, and that's what we're going to do here. So then part B, I measured the lauric acid. Again, now it's important that I do measure the lauric acid, okay, because this is our solvent, and eventually what we're going to do is you're going to measure it in grams, okay, but you're going to want to change it to kilograms because that's how molality is expressed, okay. And then you want to know we measured the grams of the benzoic acid, and we're going to use that for molar mass, and we'll talk about that later. You can keep it grams. And then what we did the experiments, we figured out what the new freezing point is. Okay, and then what you did is you subtracted the original freezing point from this freezing point, and you come up with this point. And it's a positive number. Okay, so don't worry about being negative. Okay. Right, so now what we're going to use is this data to figure out the molar mass of the benzoic acid. Okay, so now what you want to do is try to figure out, to figure out the molar mass of the benzoic acid using this experiment, using the freezing point depression. So what we can do, keep my pen here, is we can figure out the moles of benzoic acid experimentally, and we have the grams. So once we find the moles, we have the grams, and then we can take the moles divided by, the grams divided by moles, and we'll get the molar mass. So here's a freezing point depression equation, where M stands for the molality, moles of solute per kilogram solvent, should be here, and so we get so you can write it out like this. And in that case, where the solute is benzoic acid, Ba, and the solvent is lauric acid, we can write it as the change in temperature is equal K, which is given 3.9 in its specific units, times the moles of Ba divided by the kilograms of La. All right. So all we have to do now is this is what we want to find. The moles of Ba, so what you do is just rearrange the equation. Okay, so you can see that's simple. And you get this right here. Okay. All right, now you have delta T. You have kilograms lauric acid. Make sure that you change grams to kilograms. And you have K. All right. So multiply these two together, divide by K, and you get the moles of benzoic acid. Okay, and then you have your grams of Ba, benzoic acid, from the previous slide. Divide that by the moles, and you get molar mass. Okay, so it's that simple. Show your work. Show this equation here, then plug in the appropriate values and the correct units. Show your work, and have the last previous two slides showing your data and showing these calculations, and that's it. Okay, all right.